Using the ideal gas equation, we've been able to use PV equals nRT. We've also learned about standard temperature and pressure. Now, one of the things that's important with the ideal gas equation is this part right here, the moles. Because one of the things that we've learned in this class is you can take the grams of something and then use the molar mass and put that on the bottom, and that's grams, and that allows you to convert to moles. Okay, we've done that a whole bunch of times. Okay, the abbreviation for grams is G, but grams is a form of a mass. And so this equation right here, where the moles, the letters are very similar, so pay very close attention here. The moles are equal to the grams, the mass, divided by, and this capital M here stands for the molar mass. So we know that moles are grams divided by the molar mass, or little m over big M. Okay? So what we can do is we can substitute that into the equation, the PV equals nRT equation. And the reason that's important is because if we do some algebra and move some things around, we actually can find two different things. Okay, one of the things we can find is when you calculate the density of something, you probably remember this from middle school, but that's the mass over the volume. Okay, so if we see this mass right here and this volume here, if we set this equation to have mass over volume on one side, the equation becomes this. Okay, and so one way to find the density of something is to take the mass and divide by the volume. But if you don't have the mass and the volume, then you can use this equation here, where we take the pressure, of course, in atmospheres. That capital M, remember that stands for the molar mass. So I would have to give you the gas so you could look at the periodic table to know its molar mass. Divided by the gas constant, divided by the temperature, of course, in Kelvin. So the equation for the density of a gas, again, you always want to try to use this if they give it to you. But if they don't give you the mass and the volume, then use this equation right here, which is D equals PM over RT. Okay, and PM, I think about like AM and PM. PM is kind of like the nighttime. So when I think of this equation, I think of the density equation is nighttime over, and then RT, I think of as right time. So the nighttime is the right time, like the fun time or whatever. Okay, so density equals nighttime over right time, so PM over RT. And again, I'll give you these equations on a test or something like that. Okay, and then the other equation, if we manipulate this equation a little bit, you can find the molar mass of a gas. Okay, and that equation is the density. And again, how do you get the density? Maybe this way, times R times the temperature in Kelvin divided by the pressure. Okay, now, the way I remember this one, again, kind of silly, but if you use marijuana, you're very likely you might get drug tested. And if you get drug tested, you might say that you have, and again, kind of silly, but you might have dirty, DRT, P. Okay, which means your P is going to be dirty. So marijuana equals dirty P. So just a couple of silly ways to remember nighttime over right time, and that marijuana equals dirty P, to kind of help you remember those two equations. Okay, let's look at a couple of examples. What is the density of carbon tetrachloride, CCl4 vapor, at 714 torr and 125 degrees Celsius? So right away, when they say density, the first thing I think is, can I do mass over volume? Well, I don't see any masses here, and I don't see any volumes here. So unfortunately, no, I can't use that equation. So the other equation I can use is PM, nighttime, over right time. And again, the pressure must be in atmospheres, the temperature must be in Kelvin, the volume must be in liters if there's a volume, etc. So the density equals the pressure in atmospheres. So again, remember how I do this. 714 divided by 760, and that gets us to atmospheres. The molar mass is now where, when I give you this chemical formula, you got to look up carbon and chlorine on the periodic table. So 35.5 times 4 equals 142, plus the carbon is 154. So that's 154. And remember that molar mass is grams per mole. So watch how I write this. Grams over moles. Okay, and then the gas constant again, 0.082 liters atmospheres. And then again, Kelvin mole is going to go on the top like always. And then the temperature, 125 plus 273 equals 398 Kelvin. Now again, if I've done this correctly, then everything must cancel except the units for density. So earlier when we talked about density, and I said it's mass over volume, usually that means it's grams. That's mass, right? Just like when we talked about N equals M over M. When we talked about this right here, M is mass, okay, and then V is volume, and that's measured in liters. So if we've done this equation correctly, we should only be left with grams on the top and liters on the bottom. Let's see if that happens. Atmospheres over atmospheres, Kelvin and Kelvin, mole and mole. Hey, what do you know? We've got grams left on the top and liters left on the bottom. So now I'm going to go 714 divided by 760 times 154 divided by 0.082 divided by 398. Again, use your own calculator. See if you're getting the same answer as me. Make sure I'm not making a mistake. Okay, equals 4.43. And then again, grams on top, liters on the bottom. 4.43 grams per liter. Okay, example number 2 says an unknown gas at 825 milliliters of mercury, 5 degrees, has a density of 1.5239. Find the molar mass of the gas and then tell me what gas is it. Okay, so the molar mass equation, remember, is dirty P, nRT over P. So the density in this case is 1.5239 grams over liters. R, 0.082 liters atmospheres, Kelvin mole. The temperature is 5 degrees Celsius, so that's 278 Kelvin. And the pressure is 825 divided by 760, and that'll get me to atmospheres. So 1.5239 times 0.082 times 278 divided by, and then I'm going to put this part in parentheses, 825 divided by 760 equals 32. Now, 32 what? Well, it's molar mass. Molar mass is grams per mole. Let's see if that's correct. I've got a liter and a liter here. I've got an atmosphere and an atmosphere here. I have a Kelvin and a Kelvin here. Again, if you have it set up correctly and you're using your units, notice what's left, grams over moles. Units can be really, really helpful in making sure you have it set up correctly. Now, what gas is it? I don't know. Which of these 3 gases has a molar mass of 32 grams per mole? Of course, that is oxygen. Oxygen is 16. There's 2 of them, so that is so it is oxygen. All right, last one. A gas with a mass of 42.11 grams, 75 degrees, pressure 450, in a 35.5 liter container. Determine the density of the gas. Okay, so remember the equation, nighttime over right time, but the easier way to find the density of a gas, if they give it to you, is just taking the mass and dividing by the volume. There's the mass, there's the volume. Okay, so which equation do you use? In this case, if they give you the mass and the volume, you use that one. Okay, the problem with this one is, the problem with this equation is you have to have the molar mass, right? That big M is the molar mass. Okay, we don't have the molar mass. They don't tell us what the chemical is, so we can't even look it up on the periodic table. So we actually can't use this equation. Therefore, we have to use this equation, which is easier, which is great. Wouldn't you rather use the easier of the 2 equations? Yes, you would. 42.11 grams, 35.5 liters. That's it, just mass over volume. 42.11 divided by 35.5 equals 1.19 grams per liter. And now in part B, they want us to find the molar mass. Okay, and molar mass is, again, this one that you don't have another choice. You have to use this equation. Dirty P. So I'm going to take the density, 1.19 grams over liters, R 0.082 liters atmospheres over Kelvin mole. The temperature was 75 degrees Celsius. 75 plus 273 equals 348 Kelvin. And then our pressure is at 450 torr. So, and again, just on the bottom somewhere, 450, no, not torr, divided by 760 is going to get you to atmospheres. And again, let's check. We should have grams over moles left over. Liters and liters, atmospheres, atmospheres, Kelvin and Kelvin. Grams on the top, moles on the bottom. I know I have it set up correctly. Okay, so 1.19 times 0.082 times 348 divided by, and then in parentheses, do this bottom one in parentheses, 450 divided by 760. Okay, and you should get a molar mass equal to about 57.4 grams per mole. Okay, so the ideal gas equation is really helpful when you're trying to find pressure, volume, temperature, moles, whatever. Okay, but it's also really, really helpful when you're trying to find things that are not necessarily the normal things that you're looking for when you're trying to solve a problem. Okay, such as the density of a gas and the molar mass of the gas. Okay, so these two equations, and again, if you can just remember them, nighttime over right time is density, and molar mass is the dirty P equation. If you remember those two equations, then you can always find the density, remembering this equation here as well, and you can always find the molar mass of a gas. And if they ask you, like in that question about is it oxygen or nitrogen or fluorine, this one here, if they ask you what gas is it, well, the only way you can identify gas is by its molar mass. So you find the molar mass first, and then you look at the periodic table and you figure out which one has the molar mass that you found.